So good evening everyone, it's Eliaza. I'm back again with another episode of Eliaza's Practical Sciences. Alright, so today, so before I start, please make sure to hit the like button and click on the subscribe button for more content like this, because it is with your encouragement that I will be able to create more content like this. Alright, so today we're looking at polynomial regression, and I gave a detailed explanation in my last videos about what regression is. So I said regression is a relationship between a dependent and an independent variable. That is the general definition of regression. Then we looked at linear regression. So we looked at linear regression and we said this is when there is a relationship between a dependent and an independent variable, and then when we plot them on a graph, we get a straight line heading towards the origin and extending out. So each value, that is the dependent variable y and the independent variable x, when we plot them on a graph, we get a straight line, whether in an ascending order or a descending order. So that is when we say an equation has a linear regression. Then we looked at multiple regression. So most statisticians or most data analysts or data scientists will call it multiple regression, but the actual name is multiple linear regression. So I said that multiple linear regression is when there is a relationship between a dependent variable and two or more independent variables. So that is when we have a multiple linear regression. So as well, when you plot them on a graph, we both get a straight line either in an ascending order or a descending order. But anyway, what we are looking at today is polynomial regression. So now, polynomial regression is a type of regression whereby there is a relationship between a dependent and an independent variable, and when we plot these equations, that is these points, the intersection between the dependent and independent variable, when we plot them on the graph, we get a curve. We get a curve either in a U format or in an upside down U. So that is when we say that an equation or a regression is satisfying the constraints or the conditions of a polynomial regression. So without further ado, now this is my equation here. You can see the title polynomial regression, and these are my independent variables. So you can see that each value of y here is depending on this value of x. So x is the independent variable while y is the dependent variable. So now this is my equation, as you can see. So this is the matrix that allows us to break down each value of x so that we can get the coefficients that are going to allow us to find the predicted value of y, the dependent variable. So I've already done 2 videos of regression, so I believe this concept of regression should be a bit clearer. Even though you don't have a foundation in statistics or mathematics, that is not a problem. So far you can understand what I'm trying to say. So the main aim of what I'm trying to say is that for you to get values for these y here, you need this x, and in order for us to finally arrive at a solution for y, we are going to need to get coefficients. So coefficients are values that are multiplied by our independent variable so that we can get the value of the dependent variable. All right, so I have three matrices here, and in order for me to find values for B0, B1, B2, I would need to get the inverse of A. So after getting the inverse of A, I'm going to multiply that inverse by B to be able to get the values of my coefficients B0, B1, and B2. It's the same thing I've been doing in my subsequent and past videos. Alright, so after that, I'll get the inverse of A. You can see this here. Then I'm going to multiply that inverse by B. That's all. Very straight to the point. Multiply this by this B here. Then I'm going to get for B0, B1, B2. So subsequently, I will be doing purely mathematics videos explaining all these concepts very well, how they were derived and all that. And I will be doing Python videos subsequently, so just sit tight, enjoy. Of course, it is your likes and your subscription that is going to encourage me to do more content like this, because I mean, if I don't have views and if I don't have likes, where would be the encouragement to create more content like this? Anyway, so let's jump right straight to the code. So like I said, this video, well, for you to follow along with my breakdown using Python, you need to have a bit of knowledge on Python. So I'm not really teaching about the syntax of Python here for now. Like I said, in my subsequent videos, I'm going to be teaching on that, explaining the Python programming language and what it's all about. But for now, I'm just doing I'm trying to show you how you can be able to generate machine learning algorithms and use them to solve problems from scratch using Python and mathematics. And of course, there are some inbuilt libraries in Python that allows you to be able to carry out machine learning without having to do it from scratch. But the reason why I'm doing these videos, is so that you can know what happens behind the scenes when we decide to use each of these inbuilt libraries in Python, so that you can have an idea of what is going on instead of being in the dark. Alright, so let's head on to our text editor. So now I want to get my data down. So I want to get down my data. So I'm going to create a class. So I'm using a class, like I said. So because Python is an object-oriented programming language, you need to be able to talk about its object-orientedness. And when we say object-orientedness, it requires you to create a class. So you create a class. I will just call it poly. Then inside this my class, I'll create an initializer. So initializer is a function that is created automatically the moment you create class. Alright, so if you don't create it yourself, Python creates it for you. But nonetheless, it is a function that is automatically run the moment you create a class. So I will just say time x, because this is my independent variable. So this is my independent variable, so I'm going to give it x, time x. So 1 2 3 5 6 7 8 9 10 12 13 14 15 16 18 19 21 22. Alright, so that's my x, and then my self dot speed y. So self dot speed y is going to be equal to the value for that. That's going to be alright, so my values are 100, 90, 80, 60, 60, 65, 60, 65, 70, 70, 75, 76, 78, 79, 90, 89, 99, 100. So we have to be sure that all values are the same. We have to count them just to be sure. We have a to count the other one. So I have 18 elements in my x-axis. So I want to count the other to ensure that they are of the same length. Alright, so they are the same length. So let us try to copy them now. So self dot time x copy is equal to myself dot time x. So I'll copy the other one, self dot speed y copy. Alright, so I've copied both of them. You can decide to add another copy if you want. So we would find out about that later on if we need to make 2 copies of either value. Alright, so the next thing you need to do is to get your n, of course. But before that, let's create our function. So I will create my function and I'll call it regress. Regress and pass myself parameter. So I will explain all these concepts later on when I treat Python as a programming language. Alright, so for me to find the value of n, that's going to be equal to len of self dot time x. So I said my n is the total number of elements I have in each column. If you check my picture that I uploaded, this picture, you can see that this was the first list I had. The independent variable. You can see that I stored it in a list, and the dependent variables as well were also stored in a list. Okay, so and you can see that I have 18 elements there in each list. So we have 18. So now this is an inbuilt function in Python, len, that allows us to find how many elements we have in a list. So we can also use len of self.speedy to give us the same result. So after that, we want to find our summation of x. So summation of x is equal to the sum of self.time x. So we know that our time x is our x, of course. So we want to find summation of x squared. I'm only following the equation I showed you. So you can see that we've gotten our table. So after our table, we want to find each of these coefficients, n, summation of x squared, summation of x squared, summation of x cubed, summation of x squared, summation of x cubed, and summation of x squared. And we're going to use that to find our b0, b1, and b2, multiplying their inverse by these metrics. Alright, so let's head back. Alright, summation of x squared, so that's going to be equal to sum, open a list, of course, but we are going to apply list comprehension. So you open a list and you see x raised to the power of 2 for x in self dot time x. So this allows me to be able to raise each value in my self dot time x to the power of 2, So after I am done raising them to the power of 2, I'm going to add everything together. So that is what that single line of code does. I will still be explaining properly in my Python videos. Alright, the next one we're going to do is cube and quad. Alright, so as a summation of x cubed is equal to sum of your least comprehension x raised to power 3 for x in self dot times x. Alright, so we're done with that. Now the last one is going to be summation of x quad is equal to sum least comprehension x raised to power 4 for x in self dot times x. Let's be sure we're doing the right thing. So going back to our picture, okay, that's x, which is our self dot time x. Okay, self dot time. Alright, we are correct. We are on track. Alright, so we have all we need for our matrix, our first matrix. So remember, we're looking for b0, b1, and b2. Alright, so my apologies for the light. Well, my camera is not that clear, but I hope you all can see what I'm solving. So that's all that matters. It's not necessarily my face that is important for the video. It's what I'm trying to do, my goal for this video. Alright, so let us find summation of y, summation of xy, and summation of x squared y. Alright, so head back to our text editor. So I will say summation of y is equal to sum least comprehension. Okay, not yet. So summation of y, that's going to be self dot speed y. So sum of self dot speed y, adding everything together. So for us to find our summation of xy, we have to create an empty list called xy because we haven't multiplied them yet. We haven't multiplied them yet. So we have to create an empty list xy. So what's happening here is that for each value of my x and y, I'm going to loop through both lists, my x list and my y. So my x represents my self dot time x, and my y represents my self dot speed y. So as I'm looping through the both of them, as I loop through the first element in my x axis, I'm going to take it out. That is, I'm going to get fixated on it, and I'm going to get fixated on the first element in my y list, and I'm going to multiply them together. And after I multiply them together, I'm going to put them into this empty list called xy. So I loop through my first list, my x. I take the first value. At the same time, I loop through my y list. I take the first value. Now I multiply that first value for my x and first value for my y, multiply them together, and then I add them inside this empty list. And I repeat the process again, over and over again, till I get to the last element in both my x and y. So I loop through, that is, I enter my x list again, take the second value, enter my y list at the same time. I'm entering my x list, take the second value from my y, multiply both the x and y again, and put it again inside this list, inside this xy list. So the first time when I did that, the xy list had an element after taking the two first values from my x and y, and then the second time I did that, the xy list had a new element, which was the multiplication of the two second values in both my x and y. Alright, hope that was clear enough. So for me to do that, I need to go back and copy my x again. So I'm going to make a second copy of my x. I'll copy that and then I'll paste it. So I would call this self.time x copy 1, and I'll call this self.time x copy 2. Alright, so now I'm going to look through the first one. So I'll say while self.time x copy 1. So while I'm looping through the first list, I want to look through the second list. So for y in self.speed y. Alright, so I'll create a variable called x is equal to self.time x copy 1 dot pop 0 index, and then the next one. So after that, I'm going to create a variable called result res, which is going to multiply my x and y together, and after that I'm going to add them to that list called xy dot append. So this is a function in Python that we use to add elements to a list. So this one would allow us to fill up the xy with new elements taken from x and y multiplied together. Alright, so now I would now say my summation of xy. So following my formula, following my equation, which is this, going back to that picture, trying to explain each detail. So to get this, we have gotten this already. We're trying to get this summation xy. Alright, heading back. So summation xy is equal to the sum of xy. So we're going to add them together. Now we need to find this, the last one. So before we can find the summation of x squared y, we would need to find the square of x. We would need to find the square of x. Alright, so how do we do that? So I'm going to say x squared. So we're going to use least comprehension. Open a square bracket. You say x raised to the power of 2 for x in self.time x. So x raised to the power of 2 for x in self.time x. Hope I'm correct. Self.time x, alright, yeah. So now I've gotten our x squared. So now since we have gotten our x squared, we're going to need to multiply this. We're going to need to multiply the x squared by y. So we'll get back to our equation. So what we're going to do before we do that, we are going to create an empty list called x squared y. X squared y is equal to an empty list. First of all, that is squaring x multiplying by y. Alright, so now I'll create my while loop. I'll say while x squared. So while I'm looping through x squared, I'm going to say for y in self.speed y. Now create a variable like before. Result is equal to before result I will say x is equal to x squared dot pop 0. Then say result is equal to x multiplied by y. Alright, so after that you will now call your x squared y dot append, which is going to be what? Res. So you are adding the multiplied value for your x squared y. You have multiplied this x, which represents the x squared value inside your x squared list. So now this x is representing each removed element from your x squared list, and you are multiplying it by y, and at the same time the result, you are taking the result and putting it into a list, an empty list. So after that, we want to find summation of x squared y. That's what we are looking for. That's going to be equal to what? Sum of x squared y. Alright, so that is my squared value. So I'm done. I've gotten this, and everything here. So it's time for us to find this. So for us to find our B0, B1 and B2, we're going to multiply the inverse of A by the other matrix. So matrix multiplication, the way we carry out matrix multiplication is by multiplying the first row by everything in this column. So we're going to multiply the first row by everything, get a result, multiply the next row by everything, and the next row by everything. So when we multiply the first row by every column here, we're going to get the result for B0. We're going to multiply the next row by everything to get the result for B1, multiply the last row by the one column to get our result for B2. Alright, so for us to do that, we would need to import NumPy. So NumPy is a numerical library in Python that allows us to carry out numerical computation and also linear algebra. It allows us to be able to work with matrices. Anyway, when I start doing my subsequent Python videos, I'm going to explain all these concepts properly. So you want to import NumPy. So import NumPy. Alright. So after that, we are going to create a NumPy array. So NumPy arrays are just like lists. I'm going to create a NumPy array for each of our matrices. So I'll say matrix 1 is equal to NumPy dot array in my list. So now the way we can create a matrix in Python. Now this is a two-dimensional matrix that has 3 one-dimensional matrices inside. It's just the same thing as saying a list that has 3 lists inside. That's all. So I'm going to create a list inside that array, and inside that my list, I'm going to have 3 other lists inside it. So I'll go back to my text editor now inside here. So now the first list is going to have, so from our equation, we're going to have n summation x summation square. That's going to be n summation x summation x squared. So this is what we're going to have for our first list. And then the second list is going to be our summation x squared summation x cube. Alright, so I don't want them to be on the same line. Take it to another line. The next list, or rather the next one-dimensional array, is summation x squared summation x cube and summation x quad. Alright, so this is our first matrix. So our next matrix is going to be matrix 2 is equal to the same thing, numpy array dot array. We're going to have, so this our array is going to have summation y, summation xy, summation x square y. Alright, so I'll open up a one-dimensional array that has summation y, summation xy, and summation x squared y. Alright, so we are done. Now we need to find the inverse of matrix 1. I'll just say inverse matrix 1 is equal to, I'm going to use our numpy. We're going to use our linear algebra function. So there's a linear algebra function inside the numpy module that allows us to use a function called inv. So this inv function allows us to find the inverse of a matrix. Now, it's not as if we can't find the inverse ourselves, but it's going to be very, very time intensive. It's going to take a whole lot of our time. That's why it's better we just use an inbuilt function. So in order for you to find the inverse of a matrix, you will need to find its determinant, followed by its after you found its determinant, you're going to find its transpose, and after you find its transpose, that is, you're going to invert the rows and change them to the columns. You're going to invert all the rows in a matrix and change them to the column. After you've done that, you're going to find the determinant again of each minor value. That is the minor of the transpose. You're going to find their determinant. And after that, you're going to find the adjoint of the minor. So after you have found the minor, you're going to find the adjoint. Then, to get the inverse would now be the adjoint of your original matrix divided by the determinant of your original matrix. So that's going to take a whole lot of our time to do. So that's why it's better we just use this function anyway. But like I said, I'll do subsequent videos where I will break this down so that you can understand it properly. Okay, so that's for our matrix 1. So we're going to find, so now we're going to separate each of our metrics. That is, from our matrix 1, we're going to take out each row, each array. So I'll just say array 1. Before that, we need to convert this matrix to a list. So I'll just say list matrix 1 is equal to inverse of my matrix 1 dot to list. So the toList function is another inbuilt function in Python that allows us to convert a numpy array to a list, back to a list, because numpy arrays are not the same as lists. When we look at data structures, numpy arrays are a lot faster and more efficient. They save memory when we're trying to get the result of a value compared to ordinary lists. Alright, so we would need to convert it back. So the append function does not work on arrays, and the pop function does not work on arrays. It only works on lists. Alright, so now I've converted it back to a list. So now what I'm going to do is to break them down. So I'll say array 1 is equal to my list. Alright, I didn't spell list properly. It's a list matrix 1. Alright, so array 1 is equal to list matrix 1 at the 0 index. So now what this simply means is that I'm targeting the first array which is at the 0 index. Sorry, the first list now which is at the 0 index. So array 2 is going to be equal to list matrix at the 1 index. and the next one is array 3 is equal to list matrix 1 at the 2 index. Alright, just to be correct, to be proper in our descriptions, I will just say list 1, change it to list 2, change this to list 3. Alright, so now we have been able to differentiate each of our embedded lists inside the list matrix 1. So now what we are trying to do now is to take this first one and multiply it by this guy here. So we want to take the first value, the first list that I separated, which was my list 1. It is now a list. I converted it from an array to a list. I want to take it and multiply it by this array. But in order for us to do that, we would need to convert this to a list as well. So let's go back and convert our matrix 2 to a list. So after I converted this to a list, I'll come down here and say list matrix 2 is equal to matrix 2 dot to list matrix 2 dot to list. So I have converted that as well to a list. So now let us start by multiplying our first list by our list matrix 2. Okay, so I will say list. So while, let's go fast, try and finish this on time. So while this one creates a value for y in lists matrix 2, I'll say my x is equal to list 1 dot pop 0. So I'll just say result is equal to x multiplied by y. So now remember we need b naught. B naught is going to be an empty list. So I'll just call it b naught val, an empty list. B1 val, an empty list as well. So then b2 val, an empty list. Alright, so for us to be able to break this down, so after I've multiplied the value, I'll say my b naught val dot append. I'm appending the results rest. So after that, let's just copy this while loop instead of us wasting our time, so that we can be able to plot our graph and you can see what I am talking about. So copy this, paste it down, Ctrl V, Ctrl V. Sorry about that. Ctrl V. Alright, so this is our list 1 multiplied by list 1 into b naught val. Now the next one is going to be list 2. Don't want to waste time. Multiplied by still the list matrix 2. But this time around I'm removing from list 2. We're not going to make the same mistake twice. And I'm appending it to b1 val. Alright. Now the next one is I'm removing from list 3. Still multiplying it by list matrix 2. And I'm appending it to b2 val. Alright. So we have the value of our b0, b1 and b2. So let us now find our b0, b1 and b2. I'll say b0 is equal to sum b0 val, my b0, then b1 is equal to summation of our b1 val. Okay, then our b2 is equal to summation of our b2 val. So let us see our b0, b1 and b2 to see if we are on track. So print b0, copy that, can't waste time. So print b naught b1 and then b2. Alright, so let us see what's up. So inside my shell down here, I'll run the program to polynomial regression.py. Okay, sorry, it's not going to print out yet till I call the class. So I'll call my class. It was poly, if I can remember correctly, poly, and the function was regress. Okay, regress. So I'll try and run this again and see what's up. Alright, so we have our b0, b1, and b2. Alright, so let's try and use these values to predict. Right? So let's try and see what is going to be the predicted value of y if I supply a value of 1. So now this was what we gave the algorithm to learn from. It learned using these values. Let's now see what it's going to predict if I give it this value 1. Alright, so I'm going to show you my equation. So now we are back. We've now got into the final formula which would allow us to get the predicted value of y after we've supplied our value. In our case, we only have b0, b1, and b2. So we're going to try to predict what y is going to be, provided that our independent variable is 1. Alright, so now I'll comment this out. Let me just delete it, better still. So now for us to get our hands dirty, you say y is equal to b0, which we already have, plus b1 multiplied by 1. So we know what our 1 is. Say plus our 1 is 1 plus b2 multiplied by 1 raised to the power of 2. So you say double asterisk for raised to power in Python, and you say return y. So since I'm returning a value, this will not get printed out. You have to print out the result yourself. So you see we have a predicted value of 88.4. Well, this is far away from what we supplied the algorithm. But to show you its accuracy, now let us plot a graph. Let us try to plot a graph. So we have not plotted a graph ever since in all our videos, which is not ideal. So if there's time, I will try and plot a graph for my multiple regression. But before that, let us try to plot a graph for this, our polynomial regression. So I'm going to import a special library called matplot library. So matplot library allows us to plot graphs after we have gotten values for our algorithms, or after we have solved an equation. So I'll just import matplot library.pyplot. So matplot library uses the pyplot submodule to be able to plot graphs, as it plots intersections between our x and y axis. So I'll say import it as plt. That's what I want to use to plot. So now let me plot this my x against my y first, before I show you the predicted value. That is, before I show you the curve created by my predicted algorithm. So let me plot this my time x against my speed y. Alright, so outside of the equation, you just see, so you use the plt.plot function, or plot. So that's what you use to create a graph. So what am I plotting? I'm using my poly class, and I'm accessing my time x, plotting the x-axis against very slow against the speed y. So we're rounding up anyway, just wanted to show you how it's done. And you say plt.show so you can see the graph. So I'm going to run this so that you can see what we plotted. Alright, so we still get our results, but let's wait for the graph. So you can see so this was what I supplied to the algorithm. This was what I supplied to the algorithm. It had not yet predicted its own values. So now you can save that so that we can do a comparison. So I'll just save it to my desktop as figure 1. So I've saved that. So now let us see, after we now feed the independent variables to our algorithm and the dependent variables to the algorithm. Let's see what it's going to predict. So now what I'm going to do, I'm going to use this my list. I'm going to use this list, the values, and just copy them outside. I'll copy them. Then I'll create a new, or we can even plot them. Okay, let us comment this out first. Let's comment this out because so that we can see what our algorithm is going to predict. So I'll just delete this. I'll just see my x, create a list outside, paste them inside. So to get my new y, get the new value of my y, I'll just say new y is equal to an empty list first of all. And after that, so I'm going to remove this equation. I'm going to create a for loop. I'll create a for loop. So I'll just say supplied. So supplied x, and I'll just create a for loop. I'll say for x is supplied x. So while I'm looping through this list, taking each element one after the other, while I'm looping through it and removing each element, I'm going to be imputing them inside my predicted value. So I'm going to be using the algorithm to get the predicted y, and at the same time the predicted value of y, I'm going to be putting it inside, or putting them inside this empty list here. So I'll just say poly.regress x. Oh, so rather before that, I'll just create a variable called con is equal to this, and after that I will just call my new y dot append, and I'm going to add con inside. Alright, so this allows me to impute the predicted value for y, that is each predicted value predicted by my algorithm. We're going to take that value and dump it inside the new y so that we can see the newly plotted graph by our algorithm. So after this, I'm going to say my plt dot plot. Now what am I plotting? I'm plotting my supplied x against my new y. Alright, so after that, I'm going to say plt dot show. Alright, so let's see what's up. Okay, poly.regress two are given. Okay, sorry about that. So there's a small error here. Alright, so the error is this: I didn't supply a positional argument here. And let's do that. So for my function, so that when I call my function, I will be able to supply positional arguments for the function, which is what I just did here outside of the class. So I've corrected that. So now the value for that positional argument is x, which is going to be this x inside this list. So we're going to take the first value, give the algorithm to predict, the value, we're going to dump it inside the new y, followed by the next value to get the predicted value of our algorithm. So let's see our polynomial regression. Supposed to give us a curve. Anyway, there is some error probably coming. We'll spend so much time for us to get this kind of error. Anyway, so I'll do a correction video on that so that we can see how the algorithm looks like with the curve. So instead of us wasting time here, I'm going to do a correction video shortly so that you can see how the algorithm plots that curve for us. Alright, so till next time, please make sure to hit that subscribe button and click the bell notification icon. And if you found this video very informative, you could give me a thumbs up, click the like button, or if you didn't find it informative, you could just pass it by. So till I come your way next time, my name is Eliezer and my channel is Eliezer's Practical Sciences.